everyone, I'm back again. So today we'll be starting with the second chapter of it, and the second chapter, like the second lecture, not the first exam, the second chapter. It's the first second lecture for the basic geometrical ideas. And in the last class, we have already done what are the points, what are the lines, what are the line segment, what are the rays, what are intersecting lines, what are parallel lines, what are perpendicular lines, what are curves, what are polygons, simple curve, closed curve, open curves. We have done everything in the last class, and hopefully you people have done the practice of the first chapter, that what I have taught in like till now. So now let's go proceed with the second, like what are the like topics preceding it, right? One more thing I really want to say, that please keep on practicing, because only practice will make you things important. And as I told you in the very first lecture, basic geometrical ideas and understanding elementary shape, this chapter and the next chapters, these both are correlated chapters, and these are very basic chapters. Here you will be learning the terminologies, right? And I think so I have taught you what are the collinear points, what are the concurrent points, concurrent lines, concurrent points, concurrent lines, collinear points, collinear lines, right? So this I think so I have taught you, right? So from if I give you the 2 points, right? If let us suppose this and this is a point, so how many lines can pass through this point, right? So there will be only a single one line which can pass through this point. So we have done the properties in the last class as well. So these were very important things that we did in the last class, and today let's continue with the rest of it, right? Okay, so let's get started. Okay. um, yeah, so today we'll be learning the triangles and its properties, and quadrilaterals and circle and its parts. So let's start with these. So we'll be starting with the next topic. Okay, so what is the triangle? Triangle is nothing. Triangle is basically, we did what is a polygon in the last class, right? We did what is a polygon. Polygon is basically that is a closed figure formed by the line segments, right? It's like this. If I say in the last class we have done what is a polygon. Polygon is basically formed by the line segment, that is a closed figure formed only by the line segments, right? That is known as what polygon. So if I give you like two pens, right? So can you make a closed figure with this? Can you make a closed figure with this? We did in the last class, right? So you cannot make any closed figure. Just to make a closed figure, you need minimum of 3 line segments, right? I think so. Can you see? So we need a minimum of 3 line segments, and if you're going to join 3 line segment end to end, so this kind of figure is going to be formed. And I think so very much is clear that this figure is always a what? A triangle, right? So it is said to be what? A three-sided polygon is said to be what is called as what, beta? Triangle, right? So triangle has what, beta? If I say about the properties, so it have what? 3 sides? Yes or no? It have what? 3 sides? Yes. It have 3 vertices? Yes or no? 3 vertices. Yes. So sides are what, beta? AB. Sides are what? AB, BC, or AC. We did in the last class. What are the vertices? Vertices are like this, right? 1, 2, 3. So it have vertices like A, B, and C. And it have what? 3 angles? Yes or no? It have what? 3 angles. So what are the angles? This is the angle A, this is angle C, this is angle B. So this is what? Angle A, this is angle B, this is angle C. So what are the types of angle? That is angle A, angle B, angle C. Right. Now if I say that how many diagonals does like the number of diagonals in triangle, number of diagonals in triangle. So how many triangles, how many diagonals you will have? You will have none. Now let us suppose if you're taking the point C, AC and BC will be what? Your sides. These are what? Adjacent sides. These are not diagonal. And there is no other vertices left where you can find the diagonal. So here, if you simply you take the vertex A, you can take the vertex B, you will find nothing, like you will not cannot get any diagonal. So it will not have any diagonal, no diagonal at all, right? So this is the triangle and its property. And one more thing, the proving we will do in the next class, like not this year, maybe somewhere later. I will teach you how to do the proving like of this thing. So basically, if you see that ABC is a triangle, right? So can I say that the angle sum of it, like the in angle sum of triangle is equals to what? 180 degree. This is the reason I'll tell you why, how you're going to get this 180 degree. Later on, you'll be learning the reason how I got it. There will be a proving. We'll be doing the proving later on in the class 7th, or maybe later on in the class 6, depending on the requirement, but not now. Okay. So the angle sum of a triangle is what, beta? 180 degree. Means what? If you are going to add this angle, that is angle A plus if you're going to add this entire angle B, right, plus entire angle C, which is equals to what? 180 degree. I'll give you one simple example for this, right? Let us suppose if I have a triangle, right? I had a triangle and I said that this is triangle P, Q and R, right? And I said that this angle is equals to what, beta? A triangle is only formed when the angle sum is what, beta? 180 degree, right? If you say that we can also say that a triangle is only formed when the angle sum, that is a triangle is only formed, like triangle is only formed, right? Only formed when angle sum is 180 degree, right? Is 180 degree. That's it. You cannot find the triangle. You cannot form a triangle with less than like 180. You can try with your like protector compass later on, right? You can do the practical at your home also. So if you see this, let us suppose if I made a triangle and this angle is what, like 80 degree, this angle is like 20 degree. What is this angle, right? So how you can find the third angle if you have two angles? So we know that in triangle PQR we can say that 20 it's 20 plus 30 plus 80 plus this angle R is equals to how much, beta? 180 degree. So we can say that 80 plus 100 is how much, beta? 80 plus 20 is what? 100, and 180 minus 100 will give you what, beta? That's the angle R. So angle R will be equals to how much, beta? 80 degree, right? Acha, can this triangle be formed? Can this triangle be formed if I write this angle as 59, this angle as 59, and this angle as 59? Can a triangle be formed with this? No. Triangle cannot be formed, right? Triangle cannot be formed, right? Cannot be formed, right? Why triangle cannot be formed? Because if you're going to add 59 plus 59 plus 59, so this is equals to how much, beta? This is equals to 177, right? It's 177 degree, which is not equals to what, beta? 180 degree. So you cannot form a triangle by having the angles as 59, 59, 59. Or let us suppose if I say that can you form a triangle with this, like let us suppose I give you this angle as 70, this angle as 80, and this angle as 30, right? So can you form a triangle? Yes, you can form. Yes, triangle can be formed, right? Triangle can be formed, right? Can be formed, because if you're going to add this 70 plus 80 plus 30, which is equals to how much, beta? 180 degrees. So yes, it can be formed, right? Now let's do one question over here. In the given figure, identify the three types of the triangles. So what are the, like if you see, like let's suppose this is first question, this is second, this is third, this is fourth. So first part, how many triangles you see? That is BAC, like ABC triangle, right? So you write the triangle like this symbol. With the triangle, you denote triangle ABC. And then the second is what? Triangle ADB, right? ABD, or you can write ADC or ADB, whatever you feel like, right? And then there is a triangle, what, beta? ADC. You can write in any order. Order doesn't matter, right? Question number 2. Write the names of these 7 angles. How many angles do you have, right? So this is angle 1, this is angle 2, this is angle 3, this is angle 4, this is angle 5, and this is angle 6, right or not? Yes. Now we got 6 angles, and you can see that angle A. Angle A is equals to what? Angle 2 plus angle 5 or not? Yes or no? So how you're going to write the angles? You're going to write the angles like angle 1 can be written as what? Angle ABD, or it can be written as what? Angle ABC. Because beta, agar if you're going to extend the line, doesn't matter if you're going to extend the line till D or it's C, because it's a ray, right? It's a ray. It's not saying it's a line segment. So if it's a ray or line segment, you can say like that AB is also a line segment, BD is also a line segment, and BC is also a line segment, and D is in the middle of it. So this is going to be a one straight line, and the angle is not going to same. So you can say that ABD or ABC both are same, right? Similarly, if I write angle 2, so how you're going to write angle 2? You write angle 2 as what? BAD, right? If you're going to write angle 3, so angle 3 is equals to what? BDA, right? BDA. Angle 4 is equals to what? Angle ADC, right? Angle 5 is equals to what? Angle CAD, right? Angle 6 is equals to what? You can start with D, or either you can start with B, both are same. That is DCB, or angle BC, a second. DCA. It's A, not B, my bad. It's A. It's A or angle BCA. You can write either of it. Right, now let's go on the third question. It says that write the name of the 6 line segments. How many line segments you have? You have a line segment AB, right? You have a line segment AC, you have a line segment BC, you have a line segment BD, you have a line segment DC, and you have a line segment of what? AD, right or not? There's 4 line segments. Acha, write 2 triangles which have angle B common. What is the angle B? This is angle B common. So what is the 2 triangles you have? ABC, that is angle A triangle ABC. Yes, and triangle what beta? ABD or not? Yes, ABD. Yes, so you have to just take the little bit part of it, right? Now let's coming to the what do you mean by quadrilateral? Yes, again, this is a polygon with the 4 sides, right? So this is basically a polygon with the 4 sides. Now, if let us suppose if I would have given you 4 line segments, not 3 line segments, so you can just form a closed figure like this, or you can form a closed figure like this, depending on the length, or like this, or like this, something like this, or not. So you can always make a closed figure anyhow you want to make, like this, or like this. Yeah, like this. So it's like this. A quadrilateral is basically a 4 side polygon is termed as a quadrilateral. Below is the image of the quadrilateral ABCD, right? So it have what beta quadrilaterals. Later on in the elementary shapes, we'll be learning the special types of the quadrilateral, which will be used like ever and ever, like ever. Like whenever you're going to close the eyes, these properties and these special types of quadrilaterals are basically used in the mathematics, right? So if you see that quadrilaterals have what beta 4 line segments, right? So it have like 4 line segments, yes or no? 4 line segments, yes. 4 line segments, it will be what beta? AB, it is BC, it will CD, and it is AD, right? It have what? 4 angles, yes or no? 4 angles, it have 4 angles. How many angles does it have? Angle A, angle B, angle C, angle D, right? And now if I say how many diagonals does it have? It have how many diagonals if I say to count the diagonals? So if you're going to take the vertex A, it is what? AB and AD are the sides. So AC will be your what? Diagonals? Yes or no? So your diagonal will be what? AC. Similarly, take the vertex B. So AB and BC will be your adjacent sides. So BD is your diagonal, right? Now BD is your diagonal. Now just take the vertex C. With the vertex C, DC and BC are what? Your sides. So AC is what? The diagonal from the C, which is already written. Now take the vertex D. With the vertex D, you have this side and this side as the adjacent side, like AD and DC are adjacent side. So DB is your diagonal. So either you write DB or BD, both are the same. So how many diagonals it have? It have 2 diagonals, right? It have 2 diagonals. So basically, you see a quadrilateral all around you. If you see that the top of your phone, right? If you take the top of your phone, right? This is what? A quadrilateral because this is made up of the 4 sides. The screen of your laptop is again a quadrilateral, right? The curtain, the bed sheet which you use it again a what? In the shape of like 4 sided polygon, like it is made up of the 4 line segments. So these are what beta? A quadrilateral, right? So quadrilateral, see special types of quadrilateral we'll be doing in the next class, right? So over here, that is now, as we did in the last class, that the angle sum, right? So what is the angle sum? This is like extra I'm telling you. So it's okay if you just understand, it's good, right? So angle sum of quadrilateral is how much beta? Angle sum of quadrilateral is how much beta? Quadrilateral Quadrilateral, LETARLs, right? Quadrilateral is equals to how much? 360 degree. Reason, what is the reason? That it means what beta? This angle, right? That is angle A plus angle B, right? Plus angle B plus angle C plus angle D is equals to how much beta? 360 degree, right? Why? Acha. Now, a triangle that is a quadrilateral is only possible when its angle sum is what beta? 360 degrees. So similarly, if you see this angle, that this angle plus this angle plus this angle plus this angle has to be what beta? 360 degree. The sum has to be 360. Otherwise, a quadrilateral cannot be found, right? So why? So basically, we can say a quadrilateral, like quadrilateral, only like quadrilateral only exist Yeah, only formed. Yeah, only formed when angle sum is 360-degree, right? So now this is thing clear. Now, if I give you like any question to find the third angle, like remaining angle. So let us suppose I made this a quadrilateral, right? I name this as quadrilateral PQRS, right? So I set this angle as 120-degree, this angle as like 60-degree, and this angle as like 80-degree. What will be this angle, right? So I said to find this angle. So we know that the angle sum of the quadrilateral PQRS is what, beta? 360-degree, right? So we can add that is angle P plus angle Q plus angle R plus angle S is equals to how much, beta? 360-degree, right? So can I say that angle P is what? 60-degree. Angle Q is that you have to find. This is R is 80-degree. This is like 120-degree. It is equals to what? 360-degree. Now what do you have to do? You have to just add. So it is equals to what? 260-degree plus angle Q is equals to what? 360-degree. Now we say that the three angle is equals to 360 degrees. So the last angle will be what, beta? 360 minus of 260, yes or no? So angle Q will be equals to what? 100-degree. That's it. So a quadrilateral is formed, right? Now let us suppose if I made a quadrilateral like this, right? I made this angle as 120-degree. This angle is again 120-degree and 100-degree, and this is 100-degree. Can a triangle be formed? Can a quadrilateral be formed? No, it cannot be formed. But because reason, if you're going to add all the angles, that is what, 120 plus 120 plus 100 plus 100 will be equals to how much, beta? 240, 340, and this is equals to what, beta? 440 degrees, which is not equals to what? 360 degrees. So no, a triangle, a quadrilateral cannot be formed. You can just try with any of the angles, right? Now let's coming to the illustration. Draw a rough sketch of a quadrilateral, draw its diagonal, name them. It is the point of diagonal in the interior or in the exterior of a quadrilateral. As I told you, I think so we did in the last class also, that if you're going to draw a quadrilateral, see there will be two conditions. You can draw a quadrilateral like this. This is A, B, and C, D, right? So it says that, oh, we have to draw with PQRS, my bad. So I didn't, let me just make this PQRS. You have to name this as PQRS. See, after the naming, you have to either go in the clockwise direction or either in the anti-clockwise direction. Always name it accordingly, like A, B, C, D, right? PQRS. You can say like DEF, right? So DEF, right? So you can say TEFG, right? So this is like always goes in the sequence, right? So what are the diagonals? Draw its diagonal. So its diagonal will be this. Yes or no? We did like this many times, so I'm not going to explain this again and again. So its diagonal will be what, beta? PR and SQ, right? These will be what, your diagonals, right? Yes, these are your diagonals. Okay, name them. Is the meeting point of the diagonal in the interior or the exterior of the quadrilateral? Right now, the meeting point is in what? The meeting point is what? In the interior. But think again, meeting point is in the interior. Meeting point is in interior, right? Right, but let us suppose I draw a quadrilateral like this, 1, 2, 3, and then I draw a quadrilateral like this, right? So this is P, Q, R, and S, right? So let us suppose, let me change my color, then you'll see better. Yeah. Now let's draw a diagonal, right? So PQ, if I take the chord like P vertex, PQ and PS are what? The adjacent sides. So this will be your diagonal, right? Yeah. Now let's take the side QP and SR, right? So Q and S are what? Adjacent side. PQRS. So its diagonal will be what, beta? QS or not? Yes or no? So if you give a close observation, they are going to meet what? In the exterior or not? Yes. So its diagonals will be what, beta? Diagonals will be what? Its diagonals is equals to what? Again, PR and QS. But it's like meeting point is what? Meeting point is in exterior. Yeah, its meeting point is in the exterior. This is known as what? Meeting point. Right? Yes, it's clear. Now, I think so. Now let's coming to the circle. What is a circle? The circle is a simply, now I'll give you a very simple example. What is this? A simple is a curve is like, I'll give you one example. What is this? Let us suppose you are like this, right? You are like, this is a pole, right? This is a pole. And I said that this is a rod, like rod, you rod, this is like pen is a what? A kind of rod that you cannot like shift inside. So it's like fixed. The length is fixed. You cannot just stretch out or stretch in, right? So it's fixed, it's hard. And you are standing over here, right? It's you that who's standing over here, and I leave you like I said to run. I said that you run. So how, in which direction, what will be your directions of your, like in which directions you're going to run? Just think better. So you are going to run. You cannot go inward. You cannot go outward. So how you're going to run? You're going to run in this way or not? Just try to think, because I'm doing a rough hand diagram. So yeah, this is the way you're going to draw. Yes or no? My figure is not so clear. Let me draw, or like try to make a like close good figure. Wait a minute. Let me just try. Okay, I'll give you a last shot. Let me just see that I can draw like a good figure. Okay, so wait a minute. Yeah, it's you, and this is fixed. Yeah, so I said that you run. You run in this direction, or either you run in this direction. In which direction you feel like? Okay, so if you're going to run, so this will be your figure form. Yeah, just a second. I think so. I'm very close to make a good figure, right? I made a good figure. Yeah, this is not a perfect circle because I made it from a scale, right? From a freehand pen, right? So it's like that. This is the path that which you will be tracing. Yes, this is the path you trace. Yeah, this is the path you trace, yeah, which is a path in which you move. So basically this is a like a figure is formed or not. This is a closed curve, right? It says that a circle is a simple closed curve. Simple means what? No overlapping, and it is not a polygon. It's not a polygon. Below is the image of the circle. So if you see that this point where the pole is standing, so this is known as what, beta? The center, right? And the collection of the point are equidistant. See, you can see that this distance, the distance from the center to these points are what, beta? Always same or not? Yes or no? So this distance is always same, yeah? So this distance is always fixed. Like distance is always fixed, right? Yeah. So now this distance, the fixed distance is known as what, beta? The fixed distance from center is known as what, beta? Radius is always fixed. So in a circle, how many radius that you can have? You can have infinite numbers of radius, or you can have uncountable. Infinite or means uncountable. Uncountable number of radius, yes, you can have uncountable number of radius, right? Now these are the real life examples. If you see clearly that the wheel, right, these are the wheel, and these are what? Clocks, slice of oranges, cookies, dashboard, bangles. And you see that when you travel in a like a road, so there is a like gol chakkar, we say in India. So I don't know what you say, like you see that something like when you go on a road, so many roads come from here, goes from here, here and here, like this. So they goes, so you see that there's a circular path that you go in here and there, right? So you see circle all around you, right? I have a watch right now. The clock on my hand, like in my house, is in the form of a circle, right? It's not like this. Circle means what? It's not like this. This is not circle, not a circle, right? Circle is what? If you're going to take the distance, like if you're going to take this point, the center point, this distance always remains same, right? You see that this is the center, and this distance remains the same. Similarly, if you see a clock, this distance remains the what? Same. So yeah, so this is what a circle. This is called oval. This is not circle, right? Now, coming to the part of the circles, right? So what is a radius? So if this is your center, right? If this is your center, as I wrote in the previous slide, what is a radius? Radius is basically the fixed distance from the center is known as what, beta? The radius, right? So I'll write down the definitions again. So what is a radius, beta? Radius is basically the fixed distance from, one more thing I'll just say. Okay, now just see that if I have drawn a circle like this, right? This is a circle. Okay, this one is what, beta? Center, right? This one is your radius, right? Yes, I'll draw and explain it over you. Now, this path, the path is known as what, beta? This path is known as what? Circumference. Circumference circumference of circle, right? So we can say that this is the path. This path is known as what, beta? Circumference of the circle, right? Now if I say that the fixed distance from the center, from the to the circle, yeah, we can say that this is known as what? This is a fixed distance, right? So simply we denote it by small r, small a, small b, right? So generally we denote it, generally, not specifically, generally, it is written as, it is denoted or written as like small r, right? Written as small r, right? Now, what is a diameter, right? What is a diameter? Diameter is what? That is basically, it is a line segment which has been passing through the center of the circle and has its two end point or on the the circumference of the circle. Like similarly, if I draw this figure, so let us suppose that if you're going to draw this, so can I draw like this or not? Right? So can I say that this distance is what? Your radius? Right? And this distance is also what? Your radius or not? Right? So can I say that this is like the radius or not? So diameter is basically which have its end point, on the the circumference of the circle and passing through a center, right? Okay, yeah. So basically it's a line segment, it's a diameter, it's a line segment. It is actually, before going to the diameter, I would like to take the chord first, then I'll go with the diameter, right? So let me just erase this. So first I'll go with the chord, right? I'll go with the chord first. What do you mean by the chord? Chord is nothing, right? Chord is a line segment which have its end point on the circumference of the circle, right? The entire path. If I have drawn like this, yeah, this is a chord. No, this is not a chord. Chord means what? Which have its end point on the circumference of the circle, on the circumference of the circle. So basically it means what? A chord is a line segment. It's not a line, it's not a ray, it's a line segment. So clear in your head, it is a line segment. It is a line segment which have its end point on the circumference of circle, right? Now, what do you mean by the circumference? Circumference means what? The path, yeah, the entire path of the path trace is known as what? The circumference of the circle. That's the path. Yes or no? Yes. So we can say like this, or I'll just let me just see. Okay. Okay, so that means what? Now let's go on a diameter, right? What is a diameter? Diameter is what? Diameter is generally the chord. It's a chord. Diameter, you can say it's a line segment. Now, if a line segment I'm talking about in a circle, so line segment will be a chord. So it is a chord. It is a chord. It is a chord which passes through center. Yeah, through center of circle, right? Through center of circle, right? So let us suppose I draw a circle. This is a chord, right? This one is a chord, right? Now if I say that this is a circle and a chord is passing through a circle, so it is what? A diameter? Yes or no? This is known as what? Diameter. So can I say that this is like first point and the second point will be what? This is your first point. So basically, can I say that diameter is what? 2 times the radius? Yes or no? 2 times the radius? Yes. Third is that, beta, the diameter is the longest chord in the circle, right? So diameter is longest chord in the circle. Is the longest chord in the circle, right? Yes or no? So basically diameter is the longest chord. Let us suppose I drew this like this. So is this a chord? Yes, this is a chord. This is what beta a chord, right? So it have its end point on the on the circumference of the circle, right? Now, we have learned like diameter is a chord which passes through the center. We have learned about the diameter. We have learned about the circumference. Circumference is basically the path which you trace, right? And the boundaries of the circles. We can say like circumference is what? The boundaries of a circle, that is also known as what? It is circumference, right? Now, let's coming to what do you mean by an arc, right? So first, let me teach the arc. What is an arc? That is, arc is a part of circle, part of circle, right? Part of circle, like part of a circle, you're part of circumference, I can say that. Circumference, that is like this, right? So can I say that if I'm going to take only this part of it, so this is going to be what? An arc. Can I take only this part? This is going to be an arc. If I'm going to take only this part, so this is going to be an arc. So let us suppose how these arcs are written, right? These arcs are written like this. So if I name this as AB, so you can write like this. It's denoted by AB arc or BAR. It's, you can go in the clockwise direction or in the and excuse me, or in the anti-clockwise direction. You can go in either of the way. If I write this as PQ, right? So this can be written as what beta? PQ arc or QP arc. You can write it in both the directions. So this is a symbol for the arc, basic symbol that you should know, right? Now let's coming to what do you mean by a sector, right? What do you mean by a sector? Sector is what? If you take a circle, right? You take a circle and these are what beta? Two radius. Yeah, this is your radius. This one is your radius, right? And this one is your arc, right? Yeah, this one is your arc. So you see that there is a something, region is in enclosed, like something is enclosed or not, right? This is known as region. This is not a line, this is a region. So basically sector is what? Sector is basically the region enclosed between two radii. Radii is a plural form of radii. Radii and an arc of circle, and arc of circle, right? So can I see that there will be like two things, right? So see over here, I'll just change my color and see. So this is like if you draw a circle like over here, right? So this is like one, right? This is like one sector, and this is like, I'll wait a minute. Yeah. See, this is like one sector. Yes or no? This is the one sector because this is between the arc and this. And the other one will be what? The other one will be this, right or not? Yes or no? So what happened? You can just name it like, you can just name like as like, do you have you have what beta? Two parts. One is a smaller part and the other is what? The larger part, right or not? So you can say the smaller part is known as what beta? Minor arc. The smaller part is known as what? Minor arc. The bigger part is known as what beta? The major arc. Major arc. The similarly same thing happens for the segment also, right? So what do you mean by a segment, right? What do you mean by a segment? Segment figure, if you see that if you have a circle, right? If you have a circle and you take any random chord, right? Take a random chord and you see that there is a two region enclosed. You see that there are two region enclosed over here. Wait a minute. Let me just take the highlighter. You see that this is like one region. I'll do a little bit of drawing. Just a second here. Little bit of neat drawing. I'll try to make a neat drawing. I'm not a good artist, but I'll try. Okay. Yeah. You see that this is a one region it has been formed, right? And you see that, um, yeah, this is the one region it has been formed. This is a very big highlighter. Yeah. So you can see that. Yeah. I'm just coloring this part. Yeah. There are two regions formed, right? So can you see that? Uh, geez. Yeah, you see that there are two regions. So basically there are two regions. It is again the region. This is a region enclosed, enclosed between chord and arc of circle, right? Arc of circle, right? So there are two regions, right? So which is a bigger part? Bigger part is known as what, beta? Major segment, right? So this is known as what, beta? Major segment. And the smaller part is known as what, beta? Minor segment, right? Minor segment, right? And now let's come into what do you mean by a tangent. Actually, tangent should not be taught in class 6, but it's okay. The figure is given, then I'll teach you what is a segment it is. Segment kya hota hai beta? Just think like that. If you have a circle, right? Now from the circle, now my figure cannot be accurate, very accurate. And if you see the previous slide figure also, this is not very accurate. But when you will be in the class 10, you will be doing the drawing of the tangents, right? There is a chapter name as what construction, where you will be doing the drawing of the tangents, and you can see that exactly it is what it is, right? So what is a tangent basically? So tangent is, yeah. So tangent means what? If you take like, can I say that circle have infinite numbers of points? Yes or no? Circle have how many points? Circle have what? Infinite numbers of points. So you just take one single point of it. I'm just making a big figure so that you understand well. Okay. So if you're going to take a single point of it and a line has been passing through this point only, right? If you're going to see the figure, it's not very accurate figure. If you're going to see this point, like basically a tangent is a line which passes through a single point of the circle, right? On the circle, right? So tangent is basically what? It is a line. It is a line which is which is passing through single point, through a point, or through a single point. I'll write single point because our point sometimes you get confusion, so I'll write a single point, through a single point of circle. Yeah, so this is known as what? Basically the tangent. It is just passing. So can I draw, if I take this point, so can I draw a figure like this also? Yeah, I'm just drawing a rough figure. Yes, yeah, or no? Yes or no? So you can say that a circle have like how many tangents? A circle have infinite या फिर uncountable number of tangents, infinite or uncountable number of tangents. Yes or no? Yes. Tangents. Yeah. Uncountable number of tangents, right? Now, one more thing. Now, let's talk about the regions, right? Let us suppose, beta, you draw. We did the plane surface, right? So basically, a circle is what? A two-dimensional figure. You're going to draw a circle in a sheet of a paper. Yes. So circle is what? A circle is two-dimensional figure. Circle is two-dimensional. We write 2D dimensional, yeah, two-dimensional figure. Yes or no? Two-dimensional figure. Or we can say that it is being drawn on the sheet of a paper. So it's a two-dimensional, right? Now, if I say that, if I take this point P, right, this is a center, right? This one is your what? Beta center. I'm taking a point Q and I'm taking the point T, right? So can I say that the P is what, beta? Now you see that the circle divides the plane into three parts, right? So circle, this is a circle. This one is your what, beta? Circle. Yes or no? So P is like the circle divides. We can say that circle divides the plane in three parts. Yes or no? In three parts. What are the parts? The parts will be what? The part is what? Interior of the circle. Yes or no? Interior of circle. Yes. B is what, beta? On the circle. Yes. And C is what? The exterior of circle. Right? Exterior of circle. Right? So we can say that the interior of the circle, which point lies? The point P. On the circle, point Q. Right? I'll write this point P. Right? The point P. And this I will write as point Q. This is lying on the circle. Yes. This is like point Q. Yeah. And this is exterior of the circle means what? Point T. Yes. So this is the things we have learned, right? There's space left. Yeah. Okay. Now see. What is the like? Now let's do one more question over here. Acha, one more thing can I say over here? Over here, I'll write it down because there's no space left. For here only, I'll write it down. Acha. Can I say that? Let me change the color. Yeah. If the point is in the interior of the circle, so can I say that radius is greater than the point? Yes or no? If it is lies in this, so if this is your radius, yeah, this one is your radius, right? So radius, like the point P, like over here I'm writing this point P, like I'll write like this. Wait a minute. When you don't have space, your mind doesn't work. Just a second, beta. Yeah. We can say that radius is what? Radius is greater than point P. Yeah, your distance from the center, like distance of wait a minute, I need a space for this. I can't teach you like this. No. Wait a minute, I'll just see some space, then I'll teach you this. Okay, what I'll do, I'll teach you here only. I have a space, one blank over one blank sheet I have. So I'll teach you this, right? Yeah. Let us suppose you have a circle, right? Yeah, this is a circle in the plane, right? This is a center O, right? This is a point P, this is your point Q, and this is your point T, right? And this one is your radius. Radius. So can I say that when like there are conditions when the point when the point is in the interior, when point is in the interior of circle, right? Interior of circle. So it means what, beta? The radius is what? The radius is greater than its distance, the point greater than the distance of the point. Distance is greater than the distance of the point P from the center. Yes or no? From center. Yes or no? If I talk about more mathematically, that radius is greater than that what? OP distance, right or not? Now let's talk about when, yeah, let me change the color. Yeah, when the point lies on the circle, right? On the circle. So it means what? Radius will be equals to what? OQ distance, yes or no? OQ distance, yes or no? Right? And what will be your third point? The third point will be what? When the distance point lies. Now, if I take the change the color, yes. So if I say when the point lies outside the circle, right? Outside the circle, it means what? The radius will be what, beta? The radius will is less than OT distance or not? Yes or no? Yes. So radius is less than the OT distance, or I can say that radius is less than OT distance. This is mathematical form, right? OT distance, right? This is the thing. Now let's come to the illustration which we have right now. What is the maximum number of the points of intersections of the three lines in a plane, and what is the minimum number of the point? Beta, if I'm going to talk about the maximum number of the point, right? Maximum number of point, right? So I'm going to take this line, right? Let me change the other color. Yeah, changing color is good, right? So I'm going to take this as third line, right? And let's do the other color and take this color. Yeah, like this. Yeah. So we know that a line, if I'm going to give you a line, two lines always intersect at a single point. So how many points they are intersecting? So the maximum point of intersection will be what, beta? 3 points, right? So 3 points, right? But what is the minimum number of the points, right? So we have learned, like in the last class, either in a plane you have intersecting lines or either the parallel line. So it means what? If they're not intersecting, what is the maximum number of the points of intersection of three lines in a plane, and what is the minimum number of? Let us suppose they don't intersect, as we did in the last class also. Like either the lines will be intersecting or it will be parallel. So lines are parallel, right? So this is what? L1 line, then this is what, beta? L2 line, right? And this is what, your L3 line, yes or no? So they are parallel. So all lines are parallel, so there is no point of intersection. Point of intersection, yes or no? So minimum will be how much, beta? The minimum will be what? 0, right? 0. And the maximum will be what, beta? 3 points. Yes. Now let's coming to yeah. Let's do the illustration, the fill in the blanks. Fill in the blanks in the following statement using the suitable words, right? A pages of a book is a physical example of what? A plane? Yes or no? Or it's a physical example of a quadrilateral. We can say like a plane also, it's a physical example of a quadrilateral. But today we have learned about the quadrilateral, so we'll write this as quadrilateral, right? Quadrilateral, and we can write the plane also, right? It's example of a quadrilateral and it's example of a plane, right? But basically the plane works more better, right? And ink pot has dash surfaces. It has what? Flat surfaces? Yes or no? It have what? Ink pot has what? A flat surface? Yes or no? Curved surface, it can be like this also. Sometimes the ink ponds are like this, yeah, like designer flat or like curved surfaces. Yes. And two lines in a planes are what, beta? Either intersecting or it will be what, beta? Parallel. So I think so it's better you write your answers over here as a plane, not as quadrilateral, right? Yeah, it will be plane. Yeah. Let's do this also, right? In each of the following cases, state whether you can draw the line segment on the given surface or not. A face of a cuboid. What is a cuboid? Like you see your box bed or your phone or your book is what? A cuboid or not? What is a cuboid? Cuboid is like this, right? Like this, like this. I'll just draw a figure. Yeah, can you draw a line segment on it? Yes. So yes, you can draw on it, right? You can draw a line segment like this or like this. The surface of the egg on apple, you cannot draw a line segment of it. This is no. This I think so very clear to everyone. The curved surface of the cylinder. Cylinder is what, beta? Like you eat Pringles or you eat Coca-Cola or something like that, right? Or yeah, so basically these means no, right? Now the curved surface of a cone, what is a cone? Like birthday cones, ice cream cones, can you draw or not? No, you cannot draw, so no, right? The base of a cone, the base of a cone means what? If you see the base of the cone, just a second, my laptop is yeah, see over here, can you see me? Okay, so what is the base of a cone? If you're going to take a cone, so cone has a base of what? A circle. A base of a cone is what? A circle or not? And in a circle, can you draw a line segment? Yes, you can draw a line segment. Yes, you can draw a line segment. So yes, right? Okay, thank you. And now we are done with this chapter. We are done with this chapter, and please keep on practicing from your NCRT, from Ask IITian book, and from NCRT Exemplar. NCRT and Ask NCRT and NCRT Exemplar will help you to complete like for your CBSE part. And if you really want to like enhance your knowledge, you can start practicing your Ask IITian modules. And if you have any doubt regarding it, you can ask your respective teachers in the class itself, and you can ask the doubts on the BDF, that's batch discussion forum, and it will be answered over there. So thank you, class. And if you, that's all I can say. And I think so you understood the topic very well. So next we'll be starting the 5th chapter, that is understanding elementary shapes. So these are more important, and there will be some properties which you will be learning up. And these properties will always help you like for class 7, 8, 9, 10, 11, 12, all the classes, all the time, every time. So thank you, class, and let's see in the next class. Okay. Thank you, Chair.